Last episode, one hot turned unordered words into one column each, but not every category is unordered and not every column should explode into many columns. Today, ordinal encoding for ordered categories and frequency encoding to keep high cardinality columns small. First, order. Contract is month to month, 1 year, 2 year. That's not arbitrary, it's increasing commitment. One hot would throw that order away. Here, the order is the signal, so we want to keep it. Ordinal encoding maps the categories to 0, 1, 2, but we handwrite the order. Month to month is 0, 1 year is 1, 2 year is 2. Never let the encoder alphabetize because month before 1 before 2 alphabetically is luck, not meaning. We pass the explicit list. Second problem, width. Imagine a column with many distinct values. One hot would add a column for each. Frequency encoding instead replaces each category with how often it appears in the training data. Payment methods for values become a single number per row the categories share. And the hygiene line again, the order list and the frequency counts come from train. We compute payment method frequencies on X train, then look those same numbers up for the test rows. Test does not recount, it reuses the train tally, no leakage. Here's the program. Split first, ordinal encode contract with an explicit order, frequency encode payment method from train counts, apply to test, load drop customer ID, split stratified on churn with random state 42, train and test stay separate from the first line. Ordinal encode contract. We give ordinal encoder the explicit category order, month to month, 1 year, 2 year. So it maps to 0, 1, 2 in that order, not alphabetical. Fit on train, transform both. Frequency encode payment method. We compute each category's frequency on train with value counts, then map both train and test through that train built dictionary. 4 words collapse to one number. The honesty check. Any payment method value missing from train would map to Nyan in test. So we fill unseen with 0 and assert the test column has no surprises. The frequencies on test are train's frequencies by construction. The figure puts the two encodings side by side, the contract ordinal map 012 and the payment method frequency map, the 4 bars summing to 1 on train. So, ordinal when order is real and you assign it deliberately, frequency when cardinality would blow up your width, both learned on train, applied to test. Next episode, the most dangerous encoder of all, target encoding, and exactly how it leaks if you're not careful. If this helped, like and subscribe for more.